We now are going to look at gravitational potential energy. See exactly how that fits into our work and kinetic energy learning that we've done so far. Work done by the force of gravity, we'll look at that first. And when work is done by the gravity, there's one question I want you to be able to answer. Is it positive or negative? And think about what direction the force is in and what the displacement is. So here's a case where the work done by gravity, you can see the force vector and the displacement vector are in the same direction. So that work is what? It's positive. Now if you come and look at this picture, the force of gravity is down. And in this case here, work is negative on the way up. And it's positive on the way down. So when this ball was shot up, it's the force of gravity is down, displacement's up, but then on the way down, it's positive. On the way up, it's negative. On the way down, it's positive. All right, here's an example. A gymnast springs vertically upwards from a trampoline. The gymnast leaves the trampoline at a height of 1.2 meters and reaches a maximum height of 4.8 meters. So here's our 1.2 meters. Here's our 4.8 meters before falling back down. All heights are measured with respect to the ground. Ignoring air resistance, determine the initial speed VO with which the gymnast leaves the trampoline. So I'd like you to pause the video and see if you can figure that out. I'd like you to use the work kinetic energy theorem, because I know we can use other kinematics in this. So we're going to look at this idea that work equals a change in kinetic energy. And since the person stops up here at the top, the final kinetic energy is 0. So the work is equal to negative kinetic energy. Now this is work done by the force of gravity. So the work done by the gravity is mg, that's the force, times h minus hf, that's the change in the height, and that'll equal negative 1/2 mvo squared. In this case here, you'll see the masses cancel. HO minus HF is 3.6 meters times gravity of 10. So there's 36 meters here. And we want to solve for the initial velocity. So you multiply each side by 2, and that negative sign is taken care of because HO is smaller than HF, so the negatives will cancel. So you have 72 over on this side equals VO squared, so the initial velocity ends up being the square root of 72. 6 times the square root of 2 meters per second, which should end up with an answer. Now we're going to look at something called gravitational potential energy. We know that is energy due to a position. Kinetic energy is energy due to movement. And we'll see that this potential energy is equal to mgh, which is identical to the equation we just used for work done by the force of gravity. Mg is our force, h is our displacement, so we have force times displacement gives us our work. So potential energy really is equal to the work that was being accomplished by the work that the gravity did. So here we have a hammer. It's a certain distance above this pile, and when we let it go, there's potential energy here in this hammer. When it drops down, that energy is released into kinetic energy, which then does work on the pile, driving it to the ground. So the work being done by gravity is this force times distance we just talked about, or you can look at it in terms of initial gravitational potential energy minus final gravitational potential energy. So let's look at an example. How much work is done by gravity when a 5 kilogram object moves 1.5 meters horizontally, then moves 3 meters vertically upwards, and then vertically downwards? Now, when we take a look at the amount of work done by gravity during the horizontal motion, we have work equals force times cosine theta times displacement. Or I just like to think about it as the force force that's parallel to the displacement. Since force of gravity does not have a component that's along the horizontal, this is 0 joules are done when you're moving the object horizontally. Then we move 3 meters vertically upwards, and now you get your force, 5 kilograms times 9.8 meters per second squared gives you the weight, times the distance is 3 meters. And so you end up with negative 150 joules because your force of gravity, which is down, is in the opposite direction of the displacement, which is up. And then when you go ahead and move it vertically downwards, you get the 150, positive 150 joules because it's the force times displacement. And remember, I'm treating this 9.8 as 10. So it's 5 times 10 times 3 is 150, and it's positive because the displacement's down and the force is down. The next example is a 3 kilogram model rocket is launched vertically upwards with sufficient initial speed to reach a height of 100 meters. Even though air resistance, a non-conservative force, performs negative 800 joules of work on the rocket. How high would the rocket have gone if there were no air resistance? Now, what a non-conservative force means is that it just basically takes energy away from the system. So friction is a non-conservative force. Air resistance is a non-conservative force because once that energy is gone, it can't get it back. It doesn't allow energy to be conserved through kinetic energy and potential energy. So anyway, we take away this negative 800 joules of work on the rocket. So I'd like you to pause the video, see if you can figure out how much higher it would have gone. Or actually, they want to know how high the total height would have gone. So pause the video, see if you can figure it out. The answer to this is equal to 127 meters. And the way you can figure this out is just take the 800 joules that the non-conservative force did and use potential energy equals mass times gravity times height. And so it would have gained an additional 800 joules of potential energy. That 800 joules would have equaled mass times gravity times height. So you would have had 3 kilograms times gravity times the height. So that would have been that additional height, h. So you really, that height is really the 800 joules divided by the 30 newtons, which is additional 27 meters. And so that means that since it went up to 100 meters, and then you have this additional 27 meters now due to this 800 joules that you gained, it's 127 meters total that it would have gone up.